So yeah, my name is Jani. I just realized that I've been developing websites and web applications for 15 years, which is quite literally half of my entire life, which is pretty crazy if you think about it. But for the last 4 years, I've been working almost exclusively with React. And right now I run the London office for Formidable, where we're basically full in on React. But you might be wondering, why would anybody get on stage in 2018 and talk about React at a front-end conference? It's been around, since 2013, and pretty much everybody in this room has already heard about it and knows what it is, because we had many talks about it today already. And it's true, React is not exactly the new hotness for a front-end developer. But in fact, it's now at that exciting part of the life cycle where it's become so mainstream that even insurance companies are using it. And you know that when those guys get on it, you're no longer hip and cool. But here's the twist for this talk. Instead of talking about making web frontends, we're going to talk about everything else except web frontends. So in the next 40 minutes, I want to talk about, at a very abstract level, about making things in React. And that said, this isn't a React tutorial. There's so many great resources for that already. Instead, I hope that by the end of this, I'll have inspired you to, like if you haven't used React yet, you'll go after this and look more into it. I'll start by giving a little bit of background about React and its motivations and what makes it interesting. And then I'll show you some really, I think, amazing things that we can do with React today. And I'll finish briefly talking about what I think is the future for React and for web front-end development in general. So here's a brief oral history of web development as I remember it. Specifically, I'm referencing the period starting around 2002, when we first started to build applications that are a bit more ambitious than just rendering content that the server sends you. And I'm not sure how much of this is my mind rewriting history, but I think, like the way I remember it, is that it really used to suck. Like web application development for the browser was the absolute worst thing you could be doing. And I'm not a scientist, but I tried to make a chart to explain why that is. And the thing is that in this period, we were getting more ambitious with our app. Suddenly, not only did we need to make things that looked nice, but they needed to be real-time, run in 60 FPS. And then we got kind of fine with that. But then now they needed to run 60 FPS on a cheap Chinese Android phone where the chip is basically made out of like recycled toilet paper. So the browser is a very challenging environment to build applications. And even today underneath, even though we've souped it up to the hilt with all kinds of things, the browser is essentially a glorified Microsoft Word. It's a document rendering engine. So it's not the best place to create things that are typically reserved for the application domain. And to add insult to injury, on the yellow bar there, I don't think that our ability to ship for this platform was actually increasing that much. We had, first things after, first we had DOM manipulation, then we have things like Prototype, jQuery, Dojo. Then we got the first generation single page applications like Backbone, Angular 1, all that kind of stuff. And we needed to deal with things like DOM manipulation and keeping state all over the place. And that, I think, is the biggest problem that we had in the era of Ajax applications, is that we needed to start managing our application state over a longer period of time. As programmers, I think our brains are really well wired at looking at code and see what it does. And if it's not, it's okay because we can run through it in a debugger. But that very same smart brain also really sucks and struggles when it needs to try to compute and kind of keep the state of a program flow over a long period of time. An easy way to see this in action is when writing apps in, for example, in just basic jQuery and progressive enhancement, or even Angular for that matter, is that most bugs don't hit you on the first render. The bugs start to creep up when the page is kept alive for a longer period of time and updated incrementally until it gets into a state that we as programmers hadn't really anticipated or thought of or tested for. And worst of all, this would cause the kind of bugs that our users and testers would report, but we were not able to reproduce because maybe the root cause was something the user had done a minute earlier, or maybe something totally invisible, like 2 Ajax requests just landed in a different order than they did in your normal case. And this wasn't a very productive way of working. This tendency for us to be great at computing state, over time, has been not being great at it has been known for a long time. To very broadly paraphrase Edgar Dijkstra, and you always need to quote Dijkstra when you get on stage, is that we should strive to write systems that, even though they might deal with incrementally changing states, they should look like they don't. And we should have an abstraction that should allow us to reason about the state of program by simply reading the source code. The way to approach this principle is to make our systems declarative. So instead of imperatively telling, now you do this, now you do that, now you do that, you basically declare what the system should do, and then it should go and do it. I think Ben talked about this earlier. And we've known this for a long time too, because like web development used to be like this. You send a request to the server, you maybe fetch some content from a database, you template it in HTML, and send it back, and there was no state. This was really simple for us to do. And then IE implemented XML HTTP request, and it's been really downhill ever since. A few developers at Instagram and later at Facebook were aware of this problem, and that's why they wrote React. And ironically, I think React's killer idea was to go back to what we were doing before. In React applications, anytime the application state changes, whether it's in response to a user event or an incoming HTTP response or on a timer, the entire application re-renders from ground up every single time. And the upside of this method is that in order to understand the app state, all you need to do is read the code. The rendered outcome will always be a pure function of the state that we've snapshotted. But the downside of this, of course, is that if we implemented this naively, it would be really slow to re-render the entire application, and not to mention the fact that you'd lose any state that lives in the DOM itself, like text input values or scroll positions and things like that. But thankfully, React isn't implemented naively. And I want to really briefly look at how React actually works, because that'll help us understand everything that comes after. If you're already familiar with this, I apologize. I promise to be quick. And if you haven't seen React code, I apologize, because this will be very quick. So this is HTML. Hope you can read that. It's a very simple fragment of HTML. We have a div. Inside there's a span that has some text in it, and then we have an image. Very, very simple. Now in React, this looks almost identical. We define UI in syntax called JSX. The only change really is that instead of defining our style as a string, it's now an object. And because this is a dynamic expression, we can interpolate values in there. And here, just for example, I've passed in the city as a property instead of hard coding it. And this looks very much like any templating language you've ever seen, like mustache, like handlebars, like Jinja. But the big difference is that this is all actually JavaScript. And if you've seen React, this doesn't come as a surprise to you. Instead of defining templates as strings, they're defined as JavaScript code, which is pretty neat because it gives you the full power of the JavaScript programming language to essentially define your UI. But the only problem here is, somebody might have pointed out that you can't just drop HTML in your JavaScript like that and expect it to work. And that's what the JSX language does for you. It's a preprocessor that reads through your code and finds these HTML syntax expressions and turns them into very simple method calls. There's this method called React create element, and every JSX tag just turns into a call to this thing. That's not very complicated. It's a very simple preprocessor. But what's far more interesting is what React create element actually returns and what happens to those elements that are created during this render. So in React, we think in components that you can compose fully arbitrarily. And each of these components returns a tree of elements. For example, our greeting component returned a div and a span and an image, right? And React component can, of course, render other React components, which is very powerful. And these components kind of form a big tree shape, right? And once that tree is rendered, we end up with one big tree of nodes. Except instead of being actual DOM nodes, they're just very, very lightweight descriptors of what a DOM node is and represents. It essentially decouples the idea of the DOM implementation from the descriptor. And this elementary is often called the virtual DOM or VDOM, which is probably a term that you've heard. Now, this virtual DOM tree is passed to this top-level render method. And this package then turns virtual DOM into actual DOM. And although I said that React re-renders the entire application at once, it actually doesn't. It only provides the illusion that it does. So this is what's happening basically internally is React takes the virtual DOM tree, compares it to the previous version of the DOM tree. As an outcome, it finds out what is the minimal set of changes that we need to apply to the DOM, put it in a queue, execute it in a batch. Very simple stuff. But this turns out makes for an API that's really easy for programmers to reason about, but it's also extremely performant because you can actually optimize everything at the single render point, and you never read and write from the DOM alternatingly so you don't cause reflow. But now, if you went to a job interview and you saw trees on a whiteboard, it's probably not the kind of company you want to work for, unless it's Facebook. But you went to a job interview and you were asked to whiteboard a diagram of a system like this. You'd probably draw something like this. You'd start with the input and the output, and then to keep a nice separation of concerns, you probably separate the thing that diffs the things from the thing that writes to the DOM, because we're kind of taught to do this as software engineers, find the separation of concerns. And if I was the interviewer, I'd go like, yeah, this makes sense. The only thing I'd probably improve a bit is the naming. I mean, naming is hard, it's not your fault. I'd probably call the thing that diffs the things, I would call that a reconciler, because it reconciles the differences between the two VDOM trees and finds out what actually needs to update. And let's call the thing that renders the things a renderer, because it renders the things. But technically speaking, there's a lot more to React, but this is at a very high level what React actually does. Now, the separation of concerns is enforced to the point that these different behaviors are even split into different NPM packages. The React core package does all the heavy lifting of figuring out which bits of UI need changing, as well as things like batching and scheduling and prioritization, all these kind of like complicated things that makes the system incredibly fast and gives us those great qualities for to program declaratively. The React DOM package itself is a relatively simple module that just receives instructions and executes them against the DOM. And it's conceptually very simple, although the code is quite complicated because it's very, very optimized. But now that we've established this neat separation of concerns, it may occur to somebody that, hey, what if we took that React DOM module and replaced it with something else? What if we took React DOM and replaced it with React foo? I've written like maybe 1 million functions that do something with foos, but I don't know what a foo is. So let's use a better example. Let's say that, for example, if there was a way for us to replace the DOM renderer with something that would actually render natively on a phone. So what would we have to do for that? We'd probably have to write a renderer that can render UI views on iOS and Android views on Android. And then we'd probably have to write those renders natively for each platform, because you can't actually do that with JavaScript. That'll be a lot of work, but if we did it, I think what we could do is that we could write React applications and have them render natively on iOS and Android. And that would be pretty cool, because then we'd get all the cross-platform reusability benefits of JavaScript. Also, we get to program in JavaScript, which we as front-enders like. And the apps would still look and feel completely native, because underneath they would be. And I guess by now, probably everybody's caught up to my ham-fisted speculative narrative device, what if? I'm of course talking about React Native, which is a very real thing that exists today. Just hands up, is there anybody here who's hearing about React Native for the very first time today? Good. So yeah, it's an open source library, exists today. It uses exactly the same copy of React internally as it does on the web. And you can use all the knowledge you have accumulated. You can use all the libraries that you like. Same state management. You can use Fetch for networking. You can use Flexbox for layout. It's literally, the point I'm trying to make here is that if you know how to make web apps with React, you know how to make mobile apps in React Native. And it works really well. Over the last couple of years, my team has shipped, I think, around 10 mobile apps with React Native, and it keeps getting better and better. And this thing is real. It's not just like a niche toy, or like, oh yeah, you can make some crappy things with JavaScript. It won't be as good as native. It's actually used out there. I think the biggest apps today using React Native are Facebook, which is the most used app in the world, Instagram, Airbnb. These all use it partially. They're not all full React Native. The Skype app was just rewritten from scratch purely in React Native. The new PlayStation app is React Native. So with companies like Facebook and Microsoft and Sony backing this technology, it's real and it's not just hype. And the community side, it has over 50,000 stars, which is really poor metric. What is a better metric, and you probably can't see that very well here, is that last year it was the project with second most contributors on GitHub. It had over 8,000 individual contributors pushing code to React Native. So it's a thing that actually lives and breathes and works. Now, very briefly, before we get into the cool demos parts of this talk, what does React Native do? This is the code that we looked at earlier, the div, span, image, soup. This looks fine, but these names are very implementation specific. Div what does it even mean? I don't even know what div means. There's a span, there's IMG, but these are just things what the browsers decided to call them years ago. For React Native, we just renamed these primitives to something that represent more logically what it is, what they describe. So instead of a div, we have a view. Instead of a span, we have a text. And instead of IMG, we have an image. And there's a couple of tiny little UI changes, like image source is passed as an object instead of a string. But hey, this is basically the same things. And to repeat myself, if you knew how to make the previous screen in React and HTML, you know how to make this screen in React Native, which is very cool. And now some of you might be thinking, we've heard this all before. If you remember the Java catchphrase, write once, run everywhere, you probably agree that the reality did not exactly match the advertised. So Clearly, for all these highly disparate platforms, that's not a feasible goal to write code once and run it everywhere, because they're too different to be applied from a single code base. But if you think about it as a developer, you don't even necessarily want to write your code once to the lowest common denominator. Instead, you want to reuse the parts that make sense to reuse and write platform-specific implementation where the behavior differs. So the React motto, React Native motto instead is learn once, write everywhere. So what you do want is the common programming model between platforms. The biggest problem for product organizations that are shipping roughly equivalent functionality for different platforms isn't the manual work of translating lines of code to different languages. The problem is that the programming models are so different, so you actually need to invent all these things multiple times. You need to write them very differently, which is huge engineering effort and a huge source of bugs and a maintenance burden. So with this approach, you as a developer are then free to create appropriate abstractions to decide which parts you should reuse and which part you should implement platform specifically. And I think the best way to explain this is just like to show a little example, a little demo. So the example that I'm going to be showing today is something called Victory. This is an open source library that we built at Formidable. It's a data visualization library. You can basically create charts. You have all your basic chart types covered. And we built this because either existing chart libraries weren't very customizable, like the API was way too high level, or then the API was so low level that it was a lot of work to actually get things done. And with React, this gets a lot easier when you have this component-based composability model. So the goal for Victory is to make common, simple charting very easy. And I think a good way to define which type of visualization Victory is good for is that if it puts data on axes, it's probably a good fit. If it's a totally custom visualization, it probably want to stick to D3 or something. Now, this is what Victory code looks like. I realize that the code is a bit blurry, so it's kind of hard to see what's going on here. But you can maybe see roughly that there is a Victory chart component, and inside there's a Victory bar component. There isn't really that much to it. But if you create a data visualization for web with this, that's cool and that's fine and dandy. But let's say you're Airbnb, right? And you have this big app, and you want to create this data visualization that is relatively complex. It's on brand for all platforms. It looks roughly equivalent because the customer's journey doesn't only work on one platform. They actually see the thing on the web and they see the thing on the mobile, so they expect certain similarity. Data visualization isn't easy, but doing the same thing 3 times is just like you just want to blow your brains out if you're asked to do that, right? Like it doesn't feel like a very fulfilling type of work. So what we did is that we ported Victory to React Native. In the end, it was very simple for us to do because React Native supports SVG rendering. So all we have to do is inject the React Native SVG components instead of the built-in browser SVG tags, and the whole thing just works. The entire Victory API works on iOS, Android, and web. And underneath, we share like 90% of the code. But the most important part, as a developer using this library, you can share 100% of your code because Victory abstracts away the platform differences. So to illustrate the concept, here we've used the learn once, write everywhere approach to create this library. And then for a library consumer, it's a write once, run everywhere, the old Java tagline. But in practice, you are not tied to this kind of like lowest common denominator abstraction. But so yeah, anyway, we made Victory native. It's actually used in the Airbnb app today. But we had another use case. We wanted to also render charts in a terminal. Because why not, right? Since we all had a Victory and we all really like Victory, we figured why not make it render in terminals as well. The next example I'm about to show you, we have absolutely no use case for. But since we were on a roll, we figured, what the hell? So we made Victory render in virtual reality. Because, why not, right? So this is the same Victory bar chart that you would use in any other platform, but it's rendering in WebVR via something called React VR. I'll talk about React VR a bit more later, but I'll just so you get an idea of how simple this really is. This is the React VR code for that example. So we have a view, we have a panorama that sources the background assets. We have a spotlight that is like, makes things actually visible, because otherwise, nobody said let there be light, therefore there would be none. It's a reality, like you get to be the god. And then you just render a victory bar. And the only hacky thing here we do, because we haven't yet built in the React VR primitives into victory, we have to overwrite things like the data component where we pass a VR box in and a container component, which is a composite component that just says where it should be. But really, like, this code is otherwise identical to what it would be on any platform. Now, you can check these out later. Victory and Victory Native are definitely like, hardcore production, usage ready. Victory CLI is more of a hack. It works, but it's a very niche use case to have to render the terminal. And the VR is a demo at this point because we're not 100% sure if the future of data visualization in virtual reality is actually bar charts. I think you can do a lot more interesting things in there. But OK, cool. What else? What else can we do? This is going to be a bit quick. We're going to do a little whirlwind tour of cool things you can do with React. So let's start with really basic. Static sites. There's this tool called Gatsby that essentially allows you to render your React components into HTML during build time. So if you're using a static site render like Jekyll today, but you want to use React, Gatsby is an amazing tool for that. And I just want to, if anybody here is into React, want to really highlight how amazing Gatsby is. It uses GraphQL for the data sourcing, so you get this really, really nice simple code for integrating multiple data sources. It's really fantastic. We use it, for example, on the Formidable website. I think the worst things you can ask a developer to do is to make a Word document, programmatically. I think it's debasing. It's not fun. But thankfully with React, you can actually do that relatively easily. You have document primitives, you have text primitives, you have Flexbox layout primitives for certain limited things. Word isn't able to do everything. The other thing that pisses me off even more than somebody coming to me and saying, hey, could you make a Word document, is, hey, could you make a PDF? And so, well, React, I guess, problem solved. So here we have, essentially a Flexbox kind of quasi-implementation that, takes the totally messed up PDF layouting system and, abstracts that underneath Flexbox. So, that's kind of fun. If you're into making presentations, you can use something called Spectacle, which is also a library that we made. Essentially, you can make presentations, and we recently even added a slide syncing. So if I had been bothered to actually make this presentation in Spectacle, you could have all been watching it with your phones and have that sync over WebRTC. So fun stuff. But technically, this is still markup. Let's go a little bit more on the fun end of things. We saw terminal UI before, that chart, but you can actually create full graphical curses style user interfaces in React in your terminal. It works on Bash and on Windows command line, although on Windows command line it doesn't work very well because it's the Windows command line. But thankfully we have Ubuntu in Windows 10, so that's no longer a problem. We used React Blessed to create, this library is called React Blessed. It's a wrapper around Blessed, which is basically a curses implementation. And we created this thing called Webpack Dashboard, which essentially, if you're looking at your Webpack output, it's kind of hard to get any meaningful information out of it. All you can really say is that whether your build succeeded or failed. And we want to give you better insight into your bundle size. So this is what it looks like when you use Webpack Dashboard with Webpack. But recently we thought it would be super useful to add even more bundle analysis statistics and visualization. And at a certain point, this Blessed terminal interface doesn't really do it. So we decided to port the UI to a desktop app. So this is a full desktop app running on Electron on Windows and on Linux and on Mac. Electron, of course, gets most of the credit. This is not React specific. You can write any HTML in it. But the app code base here is 100% React, and we were able to reuse large parts of the terminal implementation to do that because the code is so similar. I'm just literally listing things you can make with React at this point. One of my favorite things is React GL or GL React, which renders React components to WebGL or OpenGL surfaces. I wanted to be a game developer. I wasn't smart enough to do that, so I became an app developer. But one of the things that I've always hated about GL is how hard shaders are to write and how hard they are to compose. But with React, you can render these on WebGL in a browser and via React Native on an OpenGL surface on the mobile phone. So that's kind of cool. But not all graphics require you to use GL. Sometimes basic canvas is fine. One of my colleagues wrote this thing called React Game Kit. which is basically a 2D physics engine. It uses matter.js for that. But then you define your world and your stage and your characters as React components. There's a game loop. It works kind of very Reduxy, Mobexy way. And then you just decide on each tick what to render. So it's kind of like nice and functional. That's the representation of the guy Ken who wrote it. And my absolute favorite thing to do with React is to render it into Sketch. If you are a designer or if you are working with designers, you have probably got wind that Sketch is like probably the preferred tool for most UX designers today. And earlier today we heard a really great talk about like design systems and sort of a component-based design. But what makes that extra powerful, what really soups that process up, if you can actually take your implementation and not only render it into your style guide, but also render it directly into a sketch. That means that if you have a designer or you are a designer and you want to compose a new functionality from existing components, you're not using some kind of like low fidelity mock-up. You can actually use the real component that can be backed by real data. Most of the things that I've seen done with React Sketchup just use the kind of the sketch plugin text input fields that you can feed in mock data. But just last week, I think somebody wrote a GraphQL implementation, so you can actually fetch that data from your GraphQL API to render it directly into Sketch. This is just one example of the kind of like if you think outside the box and you have a hammer, which in this case is React, you can actually do quite interesting things with it, because technically, while impressive feat, but the biggest things about things like React Sketchup is that they can fundamentally transform the way we work, right? So that's cool. And then final example, you don't even need a screen to render React, really. Like, if you think about it, you have this thing that essentially just declaratively describes some kind of state. You can actually write a render that just renders into serial port pin state changes. So you can create like hardware, like IoT implementation with React. I've never seen anybody actually like ship things with this in a serious angry way, but I'm sure that somebody's done that. What is really cool for is prototyping. Like if you want to just test out things and React and you don't want to really write all that grody code for like turning it off pins, you can just describe what it should look like and React will do that for you. Now, the reason things like React hardware works is something called Fiber, which is the latest version of the core React reconciliation algorithm. The graph, the chart that we drew earlier about the two parts, the thing that reconciles the things and things that render to things, is grossly simplified, but essentially Fiber is the way that currently React reconciles the things. And it has a lot of interesting qualities for just web development alone. You can do things like async task scheduling, which improves performance, especially in animations, because it allows us to prioritize things that are on the hot path and then do the things that can be done later. So, but the most interesting things about Fiber, the thing I'm super excited about, is that it finally makes renderers, like custom renderers, a first-class entity within React API. Basically, everything that we've seen so far, with the exception of React hardware, have been created before Fiber. And it was super hacky, and it was really complicated to create this, essentially you need to inject things into the React internals. There was an API, but it wasn't easy. And now that Fiber creates renders as the first-class API in React, I think we'll see a veritable explosion of creative, interesting things that we can do with React, because it's become just that much easier to do. So what could that future look like? What could we build? What could we build in React? We as an industry have a bit of a fanciful way of looking at the future. We have all these big ideas about what the technology of tomorrow could look like. But I think the best we can do is look at some of the most hyped up technologies of today and see whether or not we could build those in React. Virtual reality, we already touched upon. We saw the victory bar chart that renders into WebVR. And this is possible because of a project called React VR, which is created by Facebook, supported by Facebook. It's currently a lot earlier stage than anything else that Facebook has released. But it is on a kind of like same level playing field with things like React Native that are today seeing mainstream adoption. And here's a little Hello World example. Again, I apologize, the code is a bit blurry. It's written by Sunil Pai, who works at the Oculus team at Facebook. It uses React Motion, which is the same library that you probably used on the web if you've done any animations on React Web. But underneath, it renders into WebVR. So it has all these primitive components. Here we're using point light and box, which are the same basic components we used earlier. And so this is all WebVR, so it renders on Chrome today. So you can actually use WebVR to create, mobile experiences. And if you have a Samsung Gear VR, you can actually take that thing into like proper VR headset. In the future, we're hopefully going to see, mainstream support for this for things like Oculus. Oculus currently supports this via the Oculus VR browser, but it's not really something that you can easily just like load from the Oculus Rift menu. So right now, React VR is still very new and immature, but I think it's feasible that in the future we can be writing VR experiences in React. And in fact, there's this rumor that I probably shouldn't say on video, that Facebook has a React implementation for Unity. Unity being the kind of framework for creating games and creating Oculus VR experiences. And this is very exciting because essentially what it allows us to do is use this like fantastic React programming model and use JavaScript to actually create sort of like, proper VR experiences on the exact technology that all other mainstream VR experiences are built on. Well, we can't talk about hype and future without talking about augmented reality. I think it's in part of the hype cycle when usually people talk about AR, they have very little idea what they are talking about. I mean, you can have a game and you can have some kind of, experiences that, help you find things, but the actual use case, I believe, is still a bit missing. But that doesn't mean that we shouldn't do it. And you can, in fact. You can use, there's a few different competing projects for creating AR experiences with React here. I've used something called React AR Kits, which uses the iOS AR Kit underneath. There is also a third party, like a commercial company called Vero, that has created a cross-platform web, mobile, and web, iOS, and Android SDK for ARKit, and they have React Native bindings to that. It's kind of cool that you can do that, but I think what's going to really make this a reality, a possibility, is when somebody finally writes a cross-platform AR abstraction on top of ARKit on iOS and ARCore on Android. This doesn't exist today, but I bet that if I came here in a year to give the same talk, it would already exist. And I think that's very interesting because AR is fundamentally like where virtual reality is really hard to grasp and it requires immense set of kind of engineering and art design in order to be able to create a VR experience. Is like for an individual like myself or maybe you, it's going to be really hard to create something compelling in VR. But it's really easy to create something compelling in AR because the world exists. All you need to do is enhance it. And if you can do that in React, why not? Now, if we ride this hype train down its inevitable conclusion, we need to ask, is there a React blockchain? Well, the good news is that there is no React blockchain. That sounds like a pretty dumb idea until you start to think about it. Because why not? Like, that's, by the way, it's the only good use for blockchain that I've so far seen. It's securing the Catalan election. I thought that was funny. Anyway, what blockchains essentially are is they're massively distributed databases, massively distributed state containers whose state evolves over time via transactions. And this to me sounds very much like how Redux works, right? And as I talked about early on, React makes it really easy for us, the programmers, to write bug-free code for state that evolves over time. And God knows the one place we want bug-free code is in the code that holds our entire net worth in some future scenario. But could this be feasible? Could we, for example, write React for Ethereum? Ethereum has this concept of smart contracts, and what these are essentially programmable state transitions in the blockchain database. And they're written in this language called Solidity, which is like a C-style language. It doesn't look that different from JavaScript, to be honest. So I'm asking, couldn't we declaratively describe the desired state and letting someone else, for example, React, reconcile the changes for us? And then we could write this in JavaScript, and we could transpile this to Solidity via Babel, maybe? I don't know. I mean, it's necessarily not feasible. You can't actually run the React runtime in Ethereum. That would be way too expensive. But, This as an idea, I think to me what it speaks to is that this basic same mental model of React is actually applicable to like very, very diverse, situations. And finally, when we talk about hype, things, if we really go and scrape the bottom of the hype barrel, we need to talk about AI. So I don't understand AI well enough to know how we'd even begin to apply React there. But if you've seen the HBO series Westworld, where most characters are actually these artificially intelligent robots, it's a great show, and I think you should watch it. But anyway, if you freeze frame at the exactly right time in one of the episodes, you see a bit of code that the AI is programmed on. And if you zoomed in right, you're seeing that they're already using React in there. So I guess, yeah, in the future, we'll be writing our artificial intelligence bots that kill us all with React. So something to it, I think. Anyway, this leap of fancy was to highlight an actual serious point, not just a joke, which is that we don't know what the future brings. In the last 10 years, the definition of front-end, period, has changed. It's no longer about web browsers. The nomenclature of front-end comes from, you have two components into your architecture. You have the front-end and the back-end, and the front-end was the user interface. It was the way that you got pixels to screen. But today, as we all know, web browsers are by far, not the only user interface delivery mechanism that we have. Everybody has a phone in their pocket, right? And we kind of like have challenges around this as developers being specialized in one domain or one technical area, whereas like we are actually experts in a whole domain of user experience programming. And then we're coming up with new things like VR and AR, and even on existing device types, there will be new operating systems, new programming models in the future. Google is developing Fuchsia, which is a new operating system that could unify Chrome OS and Android into this one single operating system. I mean, whether or not that actually happens doesn't really matter. I'm guaranteeing you that in 10 years, we won't be programming for iOS and Android only. There will be new platforms that we need to take into account. And as a developer, this can be super scary. Like, are the things that you do today going to be relevant in 10 years' time? And I think having a set of tools and skills that work across platforms, essentially having discovered a programming model that you enjoy and makes you productive, and then having this confidence that, with some likelihood in the future, you can still continue to apply your skill set, I think to me, it's a very comforting fact that it makes me a lot more open to adapting to change overall. I think the best way to summarize this section before we answer the most important question is to quote Guillermo Rauch, who was behind products like Zeit and Now and Next.js. If you're in the React space, you guaranteed heard of him, which is that React is such a good idea that we will spend the rest of this decade continuing to explore its implications and applications. And I fundamentally believe that even though half of the things here that I showed today were hacks, maybe clever hacks, some were dumb hacks, but there are these applications to React that are so far-reaching that it's essentially what it is, in my opinion, is a game changer. So when we talk about things like React in a pub after a meetup, and then it becomes this yelling match or like this angry rant of, React versus Ember versus Angular versus no frameworks at all versus, oh yeah, just progressively enhance your HTML. Like whatever it is, I think that conversation is fine, and we can have it because we as humans are programmed to form these little tribes and like hit other tribes with rocks. But that's not the right conversation that we should be having. I think the conversation isn't what is the best web front-end framework, is whether or not we have tools in our disposal that are fundamentally useful in a larger context, whether they are good programming models, whether they're programming models that make us effective, productive. And I think React, for me, is this, and that's why I'm here talking about a topic like React. But the most important question, I think, beyond that little rant that I went on, is why? Why do any of this? Why does any of this matter? Why React is kind of an easy question to answer at this point. Whether or not you have another favorite front-end framework, React is a very good library, and it makes you productive and happier than not having it. The programming model that we've discovered in React is in no way specific to web development, so we can do a lot of stuff with it. Web apps used to suck. Web development used to suck in the app era, and then React fixed a lot of that. Mobile development used to suck a lot. Like if you've ever actually tried to write things For example, Objective-C to raw UI kit, it's just like, it's hell. Like, how do people even survive with that? Anyway, React Native has fixed a lot of that. I can't say that React VR has yet fixed VR because I don't know what the problems are, and the tooling around React VR is so immature. But things like hot reloading, which is something that React and React Native give you out of the box, also works for React VR. And you probably, one of the environments you want to be able to hot reload is a infinite world where you get to travel and see the state of the world, because otherwise if you compile and reload from scratch, you always have to start from point A. And a lot of the problems that React has solved for UI development are real problems everywhere, and these imperative APIs and implicit state management is everywhere, and React can fix that. But really, why? Like, if you go down the 5 whys category, really why? If you look at software development from a bird's eye view, it's not really about programming languages or APIs or abstractions or platforms. It's about producing value and solving problems and making things. And one of the biggest obstacles between a business and creating that value is typically time and cost. We live in a capitalist system of production after all. So today, your product's customer journey, user's customer journey might include web and mobile and email and PDFs and CLIs. But in the future, who knows what? Like, historically, teams have been split across these technology boundaries, which is very expensive and very inefficient. You have a web team, you have an iOS team, Android team, because we didn't have a shared language. And this process is really, really hard to scale. Just from a release management point of view, it's almost impossible to release a product that is multi-channel in an effective way that doesn't burn a lot of empty cycles. And having a unified programming model helps solve all this. You can create organizations that have feature teams that own certain parts of the journey, and that means that they are going to be, they're going to be aligned on all platforms, they're released together on all platforms, and they have more cohesion, and they have less bugs because you only write that bugs once and you fix it once. So yeah, finally, I think working with React and thinking of React as a kind of, like thinking of yourself as a React developer instead of as a web developer for one, is an investment in yourself. I've been working with React for, 4 years? And last 2 of them in almost exclusively in React Native. Now, I love the web, and I wasn't exactly jumping at the bit of going and creating mobile apps into these walled gardens of app stores run by corporations. I love the openness of the web. But the fact of the matter at the time was that it just kind of happened. The product I was working on at the time needed a mobile app. We considered PhoneGap, then we laughed a little bit, and then we went to React Native. And as an experience, I was so glad that we did it because it was very empowering. It stretched my reach as a developer. It made me more valuable to the team. But most importantly, it worked as a scaffolding to learn new things. If you've never done something, it can be really intimidating to do that. But React lets you get started. And along the way, I've learned Java and some Kotlin and some Swift and even a little Objective-C, although I don't recommend that to anybody. And now I'm learning VR. And I guarantee that all these things along the way, I wouldn't have jumped at with so much glee and so little fear if I hadn't had this scaffold to go with. It's not a solution. It's not a perfect abstraction. Sometimes you do need to dip underneath. But it's an empowering experience to get started. And when something doesn't work or you can figure out something, how to do it, you can just learn things. You can pick up things. It never feels like studying. I call it just-in-time learning. It's the idea that you can continuously improve yourself and build your own capital as a developer, as an engineer, as a professional. And it's kind of fun along the way. It doesn't feel like like you need to go home after work and do some studying. Anyway, I'll leave you with this. The haters say that JavaScript is a toy language, that you just simply can't go and make everything in JavaScript. And the only thing I have to say to that is that we disagree. It says, that's where you're wrong, kiddo, if you can't read the blurry text. Fundamentally, JavaScript isn't the end-all and be-all. If we think of a React as a concept, right now it's tied to JavaScript. But there are languages like ReasonML, which is a dialect of OCaml, which is a 70s research functional programming language, that essentially has React primitives built into it via something called recent React. So yeah, it's not necessarily about JavaScript. It's about the fact that it is a constantly evolving world. In a world where in a couple of years we might be writing code targeting WebAssembly instead of JavaScript, if we keep a certain core principles that we like, that we have found to be good, we can essentially continue capitalizing on all the learnings we're doing today instead of throwing everything away. Anyway, that was my bit. There was a lot of stuff that I put out there on this presentation. I will put out links to all of it or most of it on my Twitter, so you can follow me at Evakallio, which is the correct way to pronounce it. Thank you very much. That's it. Thank you.